so we're going to look at ellipses. Okay, that's section 5.3 in your book, and you don't have to write out the standard, but this is two standards we're looking at. Now, the standard is written in terms of conics, but again, included in that is ellipses. Okay, so today we're going to look at graph and ellipses, and then there's three things we're going to come up with. We're going to come up with the vertices, co-vertices, and then we're also going to write the equation of the conics. So today we're going to look at, given the equation of ellipse, how can we graph it? It's really not too terribly difficult to graph once you get the correct information. So we're going to kind of go through some definitions, and then I'll give you the formulas. Now we're going to stay at the origin, which is going to help us. But let's talk through this. All right, you don't have to write all this out, but make sure you have ellipses. Basically, an ellipse is this oval shape. Now, this one right here, okay, is longer going up and down than it is side to side. Okay, so but ellipse is a set of all points where the sum of the distance from the foci is constant. I really don't care if you know the definition per se, exactly what it is, but you need to know that this shape of it looks what it looks like. Okay, then we have a major axis. Okay, the major axis is going to be the long axis. Okay, and again, this particular one is on the y-axis, where it could also be on the x-axis, and we'll look at some of those, especially when we're graphing them. Okay, and if we split it in half, okay, that's the axis of symmetry, because we could fold it over on itself and have the same thing. So that's the major axis. Again, the major axis in this case is this, and again, it's the long axis. It's called the major axis, and then the minor axis is the shorter of the two. All right, and so again, mainly just I would jot down the graph, and again, an ellipse is an oval shape. Okay. All right, now let's look at some equations to come up with this, and we're going to talk through it. You do need to write down the equations. All right. First of all, we have a horizontal ellipse. Okay. Now go ahead and write this out, and then I'm going to talk through it a little bit, and we're going to simplify it some. Okay. An ellipse is x minus h, and then squared over a squared plus y minus k squared over b squared is equal to 1. H and k represent your center of the ellipse. Okay, that'd be the order pair for that. But since we're going to be at the origin, h and k are 0. Well, go back. H and k are 0. So what we can do is simplify this. If we're at the origin, it's just going to end up being x squared over a squared plus, okay, y squared over b squared is equal to 1. And this is the one we're going to use today. Okay? Because of what we're doing, again, we're going to be at the origin. So the center of our ellipse is going to be 0, 0. And so we don't need the h and the k. Now, the horizontal ellipse, what makes it horizontal is the fact that a squared is underneath x squared. A is always the bigger of the two. And once we do a couple of examples, I think it'll become clearer. Because a squared and b squared will switch places. But again, the larger one is always denoted with a squared. But for this one, again, our longer axis is going to be on the x-axis. So this is a horizontal one. Okay, and then our next thing is for this. I'm going to go ahead and simplify this. Okay, again, we're going to be at the origin. So what this will end up being is just, well, we'll come back to that a little for a minute in a second. But for this, we're at the origin, so we're going to have negative c and 0 for one of them, and C and 0 for the other one. Okay, so this is what we're going to use since we're at the origin. And to come up with C, C squared is equal to A squared minus B squared. And like I said, we'll do some examples of this, and I think it'll be clearer. But just know that A squared is always the bigger one, okay, and it always goes first because we're not going to end up with negative numbers. We're talking about distance here. All right, and then the only other formula is for a vertical ellipse, which is basically going to be the same formula. The only thing is the A squared and the B squared are in different locations. Ever have these two formulas? Okay. I'll go ahead and put it up here, and then the vertical ellipse. Again, we're going to be at the origin. So what we're going to end up having is x squared over b squared plus y squared over a squared is equal to 1. And the only confusion, again, is made, I think, when you first learn this, is the a squared first. Where's the a squared and the b squared go? And once we do a couple of examples, just remember a squared is always the larger one, and it'll be evident when we're looking at an equation, or if we're given the vertices, once we've talked about it, how to figure out what a squared is. Let's look at this one. We're going to do everything it tells us to do. We're going to find the vertices, co-vertices, and then we're going to graph it. Now, graphing it's not really bad either. It's almost as simple as a circle, but we need an extra point because of the way it's set up. Alright, the first thing you need to know is a squared is always the bigger of the two. It doesn't matter where it's at. You look underneath your x squared and your y squared. So in this case, a squared is equal to 36. Okay, it doesn't matter that it's underneath y. It's a squared because it's bigger than 16. Okay, so now we're going to find a. So we take the square root of both sides. So a is equal to plus or minus 6. Okay, now our vertices. Okay, our vertices is always on the long axis, okay, or the major axis of symmetry. Well, major axis. All right, but where is the 36 underneath? The y squared or the x squared? Y. So that tells us that this right here is going to be on the y-axis. Okay, so what we'll have here is 0, 6, okay, and 0, negative 6. Okay, for our vertices. Okay, and again, that's because the 36, which is our a squared, is underneath the y squared. Okay, then our co-vertices, the math is pretty much going to be the same, except we're going to denote it, we're going to call it b. So b squared, okay, remember b squared is always the smaller of the two, it's equal to 16, but we're going to take the square root of both sides, so we get b is equal to plus or minus 4. So for this, the b is located under which one? So underneath x squared, so that means it's going to be on the x-axis. So we'll have 4 and negative 4. So it'll be 4, 0, and negative 4, 0. And again, the zeros are because our center of our ellipse is at the origin. Okay, so we're coming out from the center when we talk about these. Alright, and the last thing, we really don't need this to graph it, but we're going to go ahead and find it. This one's a little bit more involved. We have to remember our little formula. C squared is equal to a squared minus b squared. Okay, now for this one, a squared was 36. B squared was 16. Alright, so what's 36 minus 16? Right, it's 20. We're going to take the square root of both sides. Now 20 will break apart a little bit for us. So that would be 4 and 5. So I can bring out the square root of 2. I can take the square root of 4 and get 2. So I end up with 2 square root of 5, okay, plus or minus is equal to our C value. Okay, now, if you can come up with this, good. We can do some review of radicals later if we need to. But for right now, that's our C value. Now, to figure out where that is, that's going to be on the same axis as the vertices. Okay, and so if our vertices is in the Y location here where we have the 6, we're going to put this in the Y location as well. So for this one, it would be 0, 2 square root of 5, and 0, negative 2 square root of 5. Okay, and so now we have 6 points. The vertices and the co-vertices are actually on the ellipse. Okay, now let's graph it. Okay, now with this, what we do is I'm going to graph the vertices first. Okay, it's in the Y, so I go up 6 for the first point, then I go down 6. And they don't have to be super pretty when you're doing these, just as long as you have the general idea. And then 4 and negative 4. Okay, now, and then we just connect them, trying to make an oval shape with this. So our ellipse should look like this.